Hey everyone, so today I'm going to talk about the UK's most studied eclogites hosted in the Glenelg Inlier in the hanging wall of the Caledonian Moine thrust in Scotland. So they provide the most robust record of Grenville-aged metamorphism in the region, and so they've carried a lot of weight for plate reconstructions and interpretations for the late Proterozoic, including in marking the position of a Grenville-aged suture as proposed by Rothstrack and others from 2020. But in what range of tectonic settings can eclogites form? So to investigate this, I looked into the petrogenesis of the eclogites from the Glenelg Inlier, the tectonic stratigraphy and sedimentology of metasedimentary rocks surrounding the Inlier, and I did a comparative analysis with some modern tectonic settings. So let's zoom in and look at the Inlier. This consists of two juxtaposed Neo-Archean blocks dominated by orthogneisses with more minor metasedimentary rocks. The Grenville-aged, so circa 1.2 to 1 GA eclogites are hosted in the eastern units, shaded green, and these occur as mafic layers and pods surrounded by more felsic amphibolite-facies gneisses. So I analyzed two contrasting samples, mafic eclogite GE3 and a felsic eclogite GE17, which we'll discuss. So the mafic eclogite shows a granular texture and shows a typical high variance assemblage, garnet, anthracite, quartz, and rutile with more minor amphibole and plagioclase. Garnet, anthracite, quartz, rutile form the interpreted peak assemblage, and these occur as inclusions within garnet, as shown in the top left BSc image. The garnets show a core to inner rim increase in grossular content, as shown in the bottom left calcium map, and this is attributed to prograde growth of the garnet. So now we look at the garnet anthracite plagioclase kinase Ge17. This consists of interlayered mafic and felsic domains. The mafic domains show the same assemblage as the mafic eclogites, whereas the felsic domains are dominated by plagioclase, as shown in the top right phase map. And the equilibrium assemblage for this sample consists of garnet anthracite, plagioclase, quartz clonozoicite, garnet, and muscovite. And these occur as inclusions within garnets, shown in the bottom right BSc image. So in order to test that these eclogites are indeed Grenville in age, I did in situ uranium-lead geochronology on both samples. These were performed by Catherine Mottram at the University of Portsmouth using their laser ablation facilities. So we got two age populations, the oldest of which is Paleoproterozoic and may be related to Laxfordian metamorphism. And the younger population occurs in the interval 1.2 to 1 gigaannum. And we attribute this to eclogite-facies metamorphism. And these age estimates are consistent with what has previously been determined for the Inlier. So I did phase equilibrium modeling on both samples using Teriak domino. Here I showed the phase diagram for the mafic eclogite with the red text denoting the observed peak field. We extended this to supersolidus conditions because the amount of melt, the predicted melt production is quite minor for such a dry rock. The stability field is limited at the lower pressure end at 17 kilobars, where plagioclase comes in at lower pressures, and at the higher pressure end at around 29 to 30 kilobars at the quartz to eclogite transition. So we wanted to place tighter constraints and did zirconium and rutile thermometry on both samples. We did not observe any systematic differences in terms of temperature between both. So here I show the 90th percentile estimates from both samples. And this further constrains the conditions to minimum 19 kilobars, corresponding to around 70 kilometers depth, and temperatures of around 750 Celsius. And these are consistent with what's been reported previously. So now we look at the phase diagram for the felsic gneiss. Again, the red text denoting the observed fields. We extend to supersolidus conditions to be conservative, again, because of minor predicted melt production. And we don't differentiate between epidote and zoisite. So again, zirconium and rutile thermometry further constrain this the peak field to between 17 and 19 kilobars and 750 Celsius. In the top right, you can see a mode box plot against pressure at a fixed temperature of around 750 Celsius. And you can see that the observed phase modes cluster nicely at around 17 kilobars, so placing us at the lower end of the stability field. So the pressures obtained from this sample are lower than what I obtained from the metamorphic eclogite, and this is consistent with re-equilibration on the retrograde path. And this is inferred from microstructures. For example, if we look at the bottom right BSC image, we can see the resorbed aspect of kyanite and peroxene. And in the mode box plot on the top right, the down pressure decrease in the mode of peroxene and kyanite, and the coupled increase in the mode of platinum-clays and garnet. So from this modeling, I constrained minimum eclogite-facies conditions to 19 kilobars, or around 70 kilometers depth, and 750 Celsius, with the felsic rock reporting somewhat lower pressures. So now I want to step back and address the question, well, where do these elusive eclogites actually come from? So I reviewed the tectonic stratigraphy and sedimentology as reported in published literature, and produced this composite figure building upon the work by Marston, Verbunnen, and others from 2022. And these metasedimentary rocks are relevant to the story of Glenelg because they were deposited in the interval 1000 to 870 Ma at around the time that the eclogites formed and or were being exhumed to their present location. So this figure shows simplified stratigraphic columns for metasedimentary rocks from the Caledonian forelands to the northwest, and in 3 overlying thrust sheets. I have here annotated paleocurrent directions as well as detrital uranium zircon data. Now, from this figure, I learned that, well, rocks across northwest Scotland, that is the metasedimentary rocks, are dominantly fluvial to mixed fluvial tidal sandstones, and occur over a stratigraphic thickness of at least 6 to 9 kilometers, which is quite thick. That they were likely co-deposited in the interval 1000 to 870 Ma, probably in a common basin, and that there is an overall southeastward flying from coarse sandstones to mixed fluvial tidal sandstones in the southeast, and shallow marine siltstones and mudstones and their metamorphosed equivalents. So the timing of deposition, the lithostratigraphy, and the basin scale characteristics are consistent with deposition within a 4-land 4-deep setting, which has previously been proposed. We also suggest that the Grenville orogen, the source of the sediments, was situated to the west. So where did the eclogites come from? Well, we think the Grenville orogen was situated somewhere to the west. However, the eclogites were transported in the hanging wall of the Moine thrust, somewhere from the east during Caledonian thrusting. So how do we reconcile this interpretation with the PT constraints? So we propose 3 options. The first presented here involves metamorphism at the base of nominally stable 4-line crust undergoing thick-skinned deformation in response to orogenic loading. We can produce the constrained PT conditions by assuming an initially thick 4-line crust, for example, 60 kilometers, as observed beneath Finland, and with an initially warm moho, so maybe around 650 Celsius, as observed beneath present-day Siberia. This is our preferred option because 4-line sedimentation can occur alongside thick-skinned deformation. So we can look at 2 modern tectonic settings where pop-up basement blocks occur beneath a 4-line basin. Those are the Shillong Plateau in the Himalayan forelands and the San Rafael block in the Andean forelands. Displacement along bounding reverse faults is on the order of 10 to 20 kilometers, producing the topographic kinds that are evident in these figures. We propose 2 other alternatives, one shown at the top involving closure of a minor oceanic basin and subduction of continental margin to eclogite-facies conditions with subsequent exhumation by restraining flow. We don't think this happens because a basin, as hypothesized, does not occur within the rock record in Scotland. And this wouldn't allow for foreland sedimentation within a common basin. Now, the final option considered is quite simple and involves eclogite formation at the base of very thick, so over 70-kilometer thick foreland crust. And we certainly don't think this happens because foreland crust of this thickness is not observed at the present day, and it would not produce the prograde record preserved within the studied eclogites. So, key conclusion from this study so far includes that the eclogites formed at least 70 kilometers depth at temperatures of around 750 Celsius in the interval 1.2 to 1 GA, and these are consistent with previous reportings. We think that the eclogites formed in the forelands of the Grenville orogen, and likely in response to thick-skinned deformation of a foreland crust. We need to be cautious in working with felsic high-pressure rocks because they can re-equilibrate on the down pressure path, as I've demonstrated. And I want to end by asking, can we mark the Glenelg eclogites as the position of Grenville-aged suture, or is there a much simpler explanation as proposed here involving formation away from a plate margin? So thank you for your attention, and I welcome any questions you might have.
Yeah. So you're saying that the eclogite and the associated gneisses are lower crustal units that have been eclogitized together?
That's right. Yeah, as a coherent package. Yes.
Okay. That's the question.
Yeah. Any more?
Yes.
Do you know of any signature of these eclogites in the Moine sediments? So is there any sign that they've been eroded and deposited into these basins?
Well, so
there doesn't seem to be a connection in here at all between their excavation.
So it's a difficult story, in part because of the poly deformation history rather hosted within the hanging wall of the Moine thrust. So we assume a simple scenario in which majority of exhumation occurred during Caledonian thrusting. The contact between the western unit of the inlier with the Moine thrust is interpreted to be conformable. Some researchers have identified conglomerates at the contact, but the contact between the eastern unit and the surrounding metasediments is tectonic.